Hey there, welcome back. In this video I'll show you what has kept me thinking for quite a while, and without further ado, let's dive into the topic. So, forced oscillations, a revolution? Maybe. Science and physics about it. The usual disclaimer. Alright, so this is something I thought on for quite a long time, almost 3 years. Though the intuition that came to me solved the last problem that was torturing me and finally wiped out all the doubts I had during this journey, I still remain open to further refinements and with my feet on the ground, because, I think it's correct by now, but you never know. This was born when I felt the need of investigating better the problem, because to me there is something wrong, and physics seems to be forcibly bent to comply mathematical equations, whereas mathematics should describe the physics and not the contrary. And by the way, I was told 1,000 times that because of a minus sign, bridges collapse. Well, maybe it's my time to pronounce the magic words. As always, English isn't my native language, so advices to improve are welcomed. And here is the summary. Topics: equation of motion, mathematical beauty, virtual phase, physical meaning, the swing analogy, symbolic set correction, phase correction, equation of motion correction, phase correction take 2, phases diagram, observations, final recap, conclusion. So topics. So straight to the points I want to discuss. First one, to me the equation we are used to deal with when describing a spring mass damper system, like mx2 dots plus cx dot plus kx equals f, has to be corrected in the same with the negative f, or even better, we can still use the first one, but with these symbolic substitutions, that is to say f minus f or negative f0, instead of the usual. Point 2, the common saying that in resonance driving frequency is equal to natural frequency is true. But we have to consider also the phase between what? Force and displacement? Yes, but it's better to focus on driving force and elastic one too. Always to me, keep in mind. Hence, the final results will be the following. This is the swing or a pendulum. So before resonance, force, driving force, and kx elastic force are synced. In resonance, somehow kx disappears, but I will show you what I mean. And beyond resonance, force and elastic force are opposite one to each other. Why a pendulum and why an elastic force on a pendulum, you might ask? Well, just follow me along and you will find out. So, equation of motion. The usual equation of motion. This equation leads to me, in my mind, at least 3 problems. First one, mathematical beauty not respected, and yes, I'm quite serious. 2, negative and virtual phase, exactly to restore the distorted or unrealistic physical meaning, and I'll show you what I mean. With the usual substitution, we have the equation of motion that becomes the one you can see, and then again this one, and then again this one, and then we have the ratio between the displacement and displacement at rest, that is equal to frequency response function, and we have a formula, and then we bring the imaginary unit to numerator with the usual trick, that is to say multiplying by 1, and we obtain this formula in which I color the parts that to me are the first alert of an underlying problem. We then take the frequency response function formula and separe modulus from phase, and we obtain these two relationships. And let's focus on the mathematical beauty aspects of these formulas. If we abstract ourselves from the vibration problems or the cyclic phenomena in general, the modulus equation can be seen as this one. And so I'll ask you, have you ever seen an equation that ugly where the highest power of the variable is shifted backwards? It's unusual, usually. Maybe when dealing with trigonometric unit circle and made substitutions between sine and cosine, but apart from that, it's quite unusual as a notation, isn't it? The virtual phase that has this expression, that minus sign, negative sign, is such a problem that there's the need of a virtual phase psi or psi introduction as correction to get back to a positive formula. Don't you smell something strange? Second alert, hint of a problem. So physical meaning, anyhow, going forward, we take the real part of x e raised to j omega t, which happens to be a cosine, the real part. So that the final result is the combination of f equals to x0 omega natural squared cosine omega t, and x, the displacement, equals to x0 absolute value of frequency response function, or dynamic amplification coefficient, I suppose, is the translation, multiplied by cosine omega t minus psi. As psi is almost zero when forcing frequency is very low and much more lower than natural frequency, that is to say in quasi-static condition, that is to say when driving force is starting to force the system, it's said that drive and position are nearly in phase as per the formulas. This means also that drive and elastic force, which is always opposite to displacement, if we multiply by stiffness and change sign to displacement, are opposite one to the other. I repeat, this means also that drive and elastic force, if we multiply displacement by stiffness and change sign to it, are opposite one to the other one. Really? To me, it's not. Physical meaning, the swing analogy. So let's consider children at play on a swing, for example, to visualize the physics of the phenomenon, and let's think at it as a big pendulum, of course. The equation of motion here is similar to a mass spring damper system, whereas the elastic force is substituted by the gravity term. So this is the schematization of the spring mass damper system. That's the pendulum. That's the equation of motion of the spring mass damper system of obviously one degree of freedom. And that's the equation of the pendulum, where damping is neglected for this example's sake. So we are driving or forcing the system from rest, that is to say, without an initial displacement x0 or theta 0 or velocity v0 or omega 0. We then take as positive the forces to the right in the spring mass damper system, negative to the left, and displacement is positive to the right of the equilibrium point from where we are starting to move, and negative to the left of it. For the pendulum or swing, counterclockwise torque is positive and vice versa. Now focus on this. We said that force and displacement are almost synced when we are quasi-static. This means that force is maximum when displacement is maximum. I omit for a moment the forces sign, but focus on your common experience, trying to remember and visualize the dynamic. Either a parent pulls back the child and let him go, but this is an initial angle theta 0, or he pushes from rest, from the equilibrium point, as hard as he can and let the swing with child go as far as it can go forward. When the child is at his highest or most distant point, the initial force has ended. Now, giving an initial angle theta 0 is not forcing from rest, but instead the starting of a free damped system. If we are forcing from rest instead, from equilibrium point, then displacement must be 0. Let's look at the equations then. For time equals 0, almost c equals 0, also 2, the set of the two force and displacement becomes this one, because time is equal 0, cosine of 0 is equal to